Hi all, my name is Gulshan working as an assistant professor AI and ES department. So this video is all about Bayesian networks. It's continuation. In the previous video we saw how Bayesian network is and how it is being represented, how it has been being implemented and all. Okay. In this video we will be seeing certain other concepts that is related with the Bayesian network. Okay. So in this we will be seeing different concepts that is allocated with the Bayesian networks and all. Okay. So the first thing is the efficient representation of the conditional distributions. Now, the conditional probability process, it cannot be handled large number or continuous value variables. It can handle only very limited process of variables. Now, the relationship between parents and children are usually describable by some other proper canonical distribution. So, we will see like what is canonical form. Use the deterministic nodes to demonstrate the relationship. The values are specified by some other functions, that is nothing but the non-deterministic or no uncertainty. Example, x is equals to f parents of x. It can be logical. Okay, how it can be logical or how it can be numerical. Now in this they have been stated some example of how North America is actually made of. It is made of Canada, US and Mexico, and how it can be non-numerical. That is, when you have a water flow, okay, you have different kinds of process, that is inflow, perceptions of it, the outflow and the evaporations. You can't actually calculate the rainfall, right? I mean the evaporations of how it is being involved and what is the process, right? So that is being implemented over here. Now in this the efficient representation of conditional distributions, you will be having one more topic, that is noisy OR. That is nothing but all possible causes are listed, that is the missings can be covered by leak node. Okay, now the compute probabilities from inhibition probabilities is nothing but the noisy OR. So how we can calculate is getting the values from the parents node, and that will be evaluated using the negation value of being implemented. Now suppose there are 3 individual inhibition probabilities and that is being followed. Okay, a person who is having cold will be having the different possibilities that is being implemented over here. That is, a person will be having cold, he will not be having fever, neither cold, he will be having cold but not a flu and malaria, and the value for this is given. Now the next thing is flu, malaria. The same thing, you are having different conditions and the values which is being given for it. So how will you calculate the probability over here? So that is the question. So this is nothing but, now see to this ratio. Calculate a value which is having a probability of fever. In that fever you should have cold as negation, flu as negation and malaria as negation. That possibility is you will be getting it as 1. Okay, the same way you are getting the other values, that is cold should be false, flu should be false, malaria should be true, and for that value you will be getting the last value, that is 0.1. okay, sorry, 0.9. okay, the value which is being given. Okay, so the negation for this will be 1 minus 0.9, that is nothing but 0.1. so this is how you will be calculating the different values. So now Bayesian network with continuous variables is when you are having many real world problems involves, it has the continuous qualifications, that is infinite number of possible values and impossible, and it is actually impossible to specify the conditional probabilities. Now what is this discretization? Discretization is dividing up of possible values into fixed set of intervals. Okay, it often results in a considerable loss of accuracy. Now again, when I come to hybrid Bayesian networks, it has both discrete and continuous variable. It has 2 kinds of distribution. One is continuous and another one is distribute. So this is the way how you will be evolved with it. So in this hybrid Bayesian networks, there is a possibility of getting a Gaussian distributed. Gaussian distributed is one of the methodology that is being implemented to find this hybrid Bayesian network. Okay, the 2 common choice is the Gaussian distribution has certain variables which is linear with the value of the parent, and the next thing is standard deviation that fixes. So there are 2 different kinds of possibilities, that is, one is subsidy should be, that is any value should be positive or the other value should be negative, and these are certain basic mathematical standard formulas that you will be using for the executions. So this is how this Bayesian network, when you plot it in a graph, or when you do it in a 3D format, you will get the graph actually of how it is being distributed. So what are the other distributions for this is distributions for discrete variables with continuous parent, and consider the Bayes node. Okay, customer will buy if the cost is low, customer will not buy if it is high. So the next two things that is correlated with the Gaussian distribution is probit distribution and logit distribution. So these are also the basic mathematical formulas that is being involved in it. So this is all about the Bayesian network and the process that is being involved in it. So I hope that you understood certain concepts that is related with unit 5. The next video we will see the case study and the certain activities which we have done in our class. Based on those activities and case studies, we have a certain methodology of learning, and that is what we will be seeing in the next two videos. As of now, thank you. Have a good day.